What if Earth was twice its current size? It sounds like a simple question, just make the planet bigger. But in reality, a double-sized Earth would transform gravity, atmosphere, oceans, ecosystems, and even human civilization in ways we can barely imagine. In this AI-powered alternate reality simulation, we will explore how life, society, and survival would change on a planet twice as large as the one we know. Part 1: The basics of a double-sized Earth. Earth today has a radius of about 6,371 kilometers. If it doubled in size, the radius would stretch to over 12,000 kilometers. Its volume would increase eightfold, and its mass even more. The immediate result? Gravity. A planet twice as large would exert nearly twice the gravitational pull on everything living on its surface. Part 2: Gravity's grip. On a double Earth, humans would weigh almost twice as much. A person weighing 70 kilograms today would feel like 140 kilograms. Walking would be harder, running exhausting, and jumping nearly impossible. Sports, travel, and even simple tasks like climbing stairs would become overwhelming. Humans would evolve shorter and stockier bodies, with stronger bones and thicker muscles. Tall, fragile builds would not survive. Buildings would also change. Skyscrapers would collapse under their own weight. Bridges, towers, and even mountains would be shorter and sturdier. The iconic skylines of our world would be replaced by squat, heavy structures built to endure crushing gravity. Part 3: The atmosphere. Stronger gravity means a denser atmosphere. Air would be thicker, winds slower, and storms more powerful. The sky would appear darker, because sunlight would scatter differently in the heavy air. Flying would be more difficult. Birds might not exist as we know them. Airplanes would struggle to lift off. Humanity might rely on blimps, magnetic trains, or ground-based transport instead of aircraft. But there's an advantage. A dense atmosphere would trap more heat, possibly stabilizing global temperatures and protecting the planet from radiation. Part 4: Oceans and land. The oceans of a double Earth would be deeper and heavier, pressing down on the crust. Continents might be smaller, with vast seas dominating the surface. Earthquakes and volcanic eruptions would be stronger due to immense tectonic pressure. Rivers would flow faster under stronger gravity, carving landscapes more aggressively. Waterfalls would be deadlier, storms more devastating, and floods more common. Life near the coasts would constantly battle against overwhelming natural forces. Part 5: Ecosystems and evolution. How would animals and plants adapt? In a world of stronger gravity, giant animals could not exist. Dinosaurs the size of buildings would never have survived here. Instead, life would evolve smaller, denser, sturdier forms. Elephants, giraffes, and whales would not exist as we know them. Insects might thrive, their small frames better suited to heavy gravity. Forests would be shorter and denser, with trees growing close to the ground to resist collapse. Human civilization would live in a world of compact, stocky animals and hardy plants. Part 6: Human civilization. How would humans build societies on a double Earth? Cities would spread outward, not upward. Transportation would rely on tunnels, railways, and dense road systems. Air travel would be rare or non-existent. Wars would be different too. Missiles and aircraft would be less effective under heavy air and gravity. Armies might return to ground-based artillery, railguns, and armored vehicles. Food production would be harder. Plants would need more energy to grow in denser air and heavier soil. Agriculture would require constant innovation just to feed billions. Over time, civilizations might cluster near areas with lighter gravity plateaus, mountains, or thinner crust zones. Part 7: Space exploration. Here lies the greatest challenge of all. Leaving a double Earth. On our planet, rockets already require massive amounts of fuel to escape gravity. On a double Earth, launching into space might be impossible with chemical rockets. Satellites, space stations, and exploration of the solar system could never begin. Humanity would be trapped on its home world forever, unable to reach the stars. Even advanced civilizations might struggle to break free. This means no moon landing, no Mars colonization, and no future among the stars. Part 8: The fate of civilization. Would humanity thrive or collapse on a double Earth? AI simulation suggests both possibilities. On one hand, life would adapt. Humans would grow shorter, stronger, and sturdier. Societies would build low, dense cities and rely on ground technology. Civilization could survive and even prosper. On the other hand, isolation from space, constant natural disasters, and the difficulty of farming could limit progress. Humanity might remain confined to a harsh, heavy planet, never reaching beyond the skies. Conclusion. So, what if Earth was twice its current size? It would be a world of crushing gravity, dense air, powerful oceans, and compact life. A world where humans adapt into sturdy survivors, but remain trapped under the weight of their own planet. This scenario reminds us how fragile our balance is. Earth, as it is today, is not just lucky, it is perfect for life. If you enjoyed this journey into alternate realities, don't forget to like this video and subscribe for more AI-powered simulations of science, history, and the universe. Thank you for watching.